Okay, so this is our first exercise, the determination of sulfur dioxide by nefelometry. So first have a look on the laboratory equipment. You collect the samples in the screw bars. So you have two screw bars. There is a flow meter, there is a pump, and you have artificial source of sulfur dioxide. Let's look at the solutions. You have barium chloride, hydrochloric acid, the absorbing solution, so the potassium chloride, and the standard solution. Now what we have to do, we have to put the absorbing solution into the screw bars. So our absorbing solution is potassium chloride. We put 10 cubic centimeters into each screw bar, and into first one and the second one. Okay, so now is our absorbing solution in the screw bars, and we have to pass the air through the solvents. So we'll put the screw bars, and we will connect everything. The important thing is that here the screw bars are connected one after another, and there is a third screw bar. This one is empty. This one is a safety screw bar. In case the flow is too high, the solution from the screw bar could go to the pump. So if we want to protect the pump, we need to use such a safety screw bar. So always remember to put something like this or a filter. The second part includes the prepare of scale of standards. So you need a standard solution. To the first tube you don't put anything. To the second you put, after the instruction, 0.1 milliliter and 0.2, 3, 4, 5, 7, 8 and 9. So the 9th is the highest concentration, and the first is 0. So we will start with the first. The important thing, remember not to blow out the solution from the pipette. It should be left like this. And the rest. There are two types of pipettes. When you look at the scale, one has 0 on the top and the second has 1.0 on the top. So the important thing is that when you want to use this pipette, you have to start from the top. You need to have full pipette. When you want to use this one, you usually take as much as you need. When you put the standard solution from the 0 to 0.9. Now you have to add the absorbing solution, so the potassium chloride. To the first tube you have to add 5 cubic centimeter, and the rest is ending with 4.1 cubic centimeter. So here is 4.9. Now we will add to 0. Again. And the first tube is 4.8. And so on. So now you have in the tubes the standard solution and the absorbing solution. We can say that the same type of solutions is in the scrubbers. So what we have to do now? We have to take 5 cubic centimeter from each scrubber and then prepare the sample. So we take separately from each scrubber. We have 2 tubes. We take the pipette and take 5 cubic centimeters, and the same to the second. When you are right-handed, you should take the pipette into your right hand. When you are left-handed, you should use the left hand. Okay, so now we have the scale of standards and our 2 samples. The important thing is that we expect that the higher concentration will be on our right sample and the lower concentration will be on the left sample, because the air goes first to the first scrubber and then to the second. Next step includes adding 0.5 cubic centimeter of the chloric acid, so we put to scale of standards and our samples. So we add ½ centimeters to each. Okay. You mix the sample. Do everything the same to all the scale of standards and the unknown samples which you have collected from the artificial source. Why the source is artificial? Because we want to check the high concentration of sulfur dioxide. If we would like to check the concentration of sulfur dioxide in ambient air, so we should take the sample of air from the outside and use another method. This is the colorimetric method, but you don't have this exercise in your plan. So the 2 last. So here are our samples. And the final step, to all of the samples you add ½ cubic centimeters of barium chloride. our samples as well. Okay, so we can mix all of the samples. Wait 15 minutes. Okay, so this is our scale of standards. I'm not sure if it's well seen, but as you see, it gets more milky with the higher concentration of sulfur dioxide. And on the back are our samples. This is the first sample. The second sample. As you see, the second sample is 0, so we don't have sulfur dioxide in the second sample, so our scrubbers collect all sulfur dioxide, and the first sample is somewhere between 0.1 and 0.2. Show it again. We take our sample, put in the middle, and on the left we put the lower concentration, on the right the higher concentration, and we are trying to compare it. It's not seen on the movie, but in my opinion it's rather the higher concentration, so this will be 0.2 cubic centimeter, and we have to calculate it into the content of sulfur dioxide and next into the concentration. Just to compare, we will compare it with the higher concentration. So we take this one on the right, this one on the left, and we compare it. It's not well seen, oh, maybe here. Better bit. So we see that this one is much more milky, and we do it again to see the difference. When we compare, this is 0.3, this is 0.4 cubic centimeter of standard solution. So here is well seen that our sample is lower. You can of course compare it with the highest concentration, and you see the difference here very well, and this will be the 0. So you see the difference. In this exercise you have to very precisely wash the equipment. You remember in the tubes there was white sediment, so you have to wash all tubes with the brush.